Welcome. This lab is going to be a crossover between biology and chemistry. So if you're in my biology and chemistry classes at honours level, then you kind of get 2 for 1. You only have to do it once for 2 subjects. If you're not, then you have to do it anyway. Last year I split it up with my chemistry classes making the Molar Solutions and the biology classes doing the Osmosis. We'll look at what those mean in a minute, but this year we're all going to do it because the osmosis is a check to see if you've made the molar solutions properly, and if you're only doing biology, then nobody's there to make the molar solutions except you at home. So here we make the molar solutions. A 1 molar solution, and listen to this definition because you'll need it later, is 1 mole of a substance. Then you place it in something, and then you fill it up to 1 litre. So 1 mole is the mass of all of the atoms put together in a molecule, and then you get that many grams. So let's have a look what we're doing today. We're doing molar solutions of table sugar or sucrose. There it is, common or garden sugar. I just found this in the chemistry lab, and it's old as old as old, but it doesn't really matter because water hasn't got to it. And here's what sucrose is. It is this molecule. It is C12H22O11. Okay? There's other kinds of C12H22O11. There's different isomers, but this one's sucrose. And it's made of like 1 monomer of glucose, alpha glucose, and 1 of fructose, fruit sugar. And they're put together by a condensation reaction, and you've got your sucrose. Now, C12. So we know that carbon, by looking at the periodic table, has an atomic mass of 12.011. So 12 of those. 12 times 12.011 be 140 something or other grams. Then we have to add to that the 11 oxygens, so it's 16 point something times 11, look it up on your periodic table, and the hydrogen, 1 point something times 22, because there's 22 hydrogen atoms in a sucrose molecule. So you could add all these up, or you could just look it up online, and you get 1 mole, you can't even see that, can you? 1 mole of sucrose is 342.3 grams in a mole. So all you do is add up the atomic masses and call it grams, and you've got 1 mole of it. I don't want a 1 molar solution of sucrose. It's too much. So if I get 342 grams, that's almost a pound of sugar in a litre. It's difficult to get that much to dissolve. Instead of that, I'm going to take a 0.1 molar solution. And so, instead of 342.3, I'm going to find that divided by 10, 34.23 grams. And so, I zero this. You can't see a thing because that's in the way. I zero this. I've got my weigh boat over here. I've been breathing on it, so I have to zero it again. And I'm going to now put 34.23 grams in here. And that will be not 1 mole, it'll be 1/10 of a mole. And I'm up to 24.4, 25, a bit more, 35.92, take a bit out, 35 point less, 34.34, just about there, 33.8, 34 point, almost there. There we go. And that's it, our 34.23 grams. And now what I do with that is I place it in this 1 litre measuring cylinder very carefully so I don't drop any on the floor. And there it is. It's at the bottom of the measuring cylinder. You can see it's quite a lot. Imagine that if it was 10 times that, 1 mole of sucrose. Really hard to get it to dissolve. And now I fill this up to the 1 litre mark. And 1/10 of a mole in 1 litre is a 0.1 molar solution. So I measure it to the bottom of the meniscus. You can tell the precision of this measuring cylinder is not great because it's such a high capacity. Oh, well done. All right, and now I have to stir this up because I want it evenly dissolved. Now what I want to do now, I do want some of that. I do want some 0.1 molar, but I want a range of molarities. So I'm going to spread them evenly between 0, which is pure water, and 0.1 molar. And the way I'm going to do that is here, I'm going to put 0.10 molar. And what I'm going to do is simply pour out 100 milliliters of that. And there it is, my 0.1 molar sugar solution. Nice. The next one's a bit harder because I want even spacing between all of my molarities. So now I'm going to do 0.8 or 0.08 molar. So 0.08 molar. There we go. And 0.08 molar, it's 8/10 the concentration of this. So I add this up to, fresh measuring cylinder, up to 80 milliliters. Notice I stir it between each one. A bit more. A bit less. And, it's still not right. And what I'm going to do now is really annoy myself because I'm doing this over and over again. A little bit more. Let's try and do it just. Yeah, good. That's not bad. And then I fill this up to 100. Here we go. With distilled water, which is taking forever, and I'm getting very bored. So now I've got, in a minute, 0.08 molar, and I put that into here. And you notice I'm not doing serial dilution like I did in one of the earlier chemistry labs. Stir it again. I'm actually just doing ratios. The next one's 0.06 molar. So it's 6/10 of my original 0.1 molar. And so I use a new measuring cylinder. I fill this up to 60. Yes! And I got bored with the other way and fill this up to 100. Oh, so that's nice. That's my 0.06 molar sucrose solution, and I forgot to write my thing on it, so that's 0.06. The next one I do is 0.04, where I will put 40 milliliters of my stock solution of my 0.1 molar, and I'll add 60 milliliters of the water. The last 0.02 milliliters, I'll fill this up to 20 and add 80 of water. And the last one, 0.00 molar, is just pure water. So this is how we make the molar solutions. We have a gradation from quite a strong sugar solution, 0.1 molar, to no sugar at all, 0, and 5 gradations in the middle.